What did you say about your butt?
Your butt is misleading.
Every time I email her, she gets mad.
Hi everyone. How's it going?
All right.
A plan here for today. We have a couple of in-class examples from 8-1 that I want to circle back, finish up, and then I want to do 8-2 and do the in-class examples for 8-2. Okie dokes. So, I think last time we were in the midst of doing this example 8, and I think we were on part C. So we had drawn this this Venn diagram. And I want to ask to find n of S union T. What does that little n out front mean? That's the number of things in that set. So how many things are in the set S union T?
Two. 40.
29.
5.
You guys are bad at stuff.
Hold on.
26.
7.
Oh, because they overlap.
7.
Okay, no. Wait, 10.
26.
12. 3.
Oh, wait.
33.
It's S.
Thank you. 33. 10 plus 5 plus 12 plus 1 plus 2 plus 3. You have to look at everything in the S circle and everything in the T circle. Okay? Then we want to get the P of S union T. What does that P out front stand for?
Yes.
Probability. Great. So what's the probability that you've chosen something in S union T?
2 over
33 over 50.
Yeah, thanks, Sam. Where'd the 50 come from?
It's the total.
Yeah, that's 50 total objects in here. So you add the other 17 to the 33, you get 50, or you could have remembered from the very beginning there, 50 total when we start. Let's keep on going. There are 105 people in the same grade as each other. The teacher finds out that some students are in the same math class, science class, and English classes. She finds that 4 students are in all 3 classes together. 12 total students are in math and science together. 5 total are in science and English together. 9 total are in math and English together. 40 total are in math. 26 total in science, and 50 total in English. Represent the above information as a Venn diagram. Who can help me fill in this Venn diagram? Wait. Am I a waiter?
What is he waiting for?
Great, give it a shot. Oh, you're gonna come up.
Oh.
That's fine.
Okay.
Go ahead. I wasn't expecting that. That's
I
okay.
couldn't read from back there.
That's all right. Reading's hard, you know, guys.
Yeah.
My daughter has a hard time with it. She's 6, but no, specifically 6. I know exactly how old she is.
When's her birthday?
August 7th.
That's the day before Jack's birthday and Lucas's birthday.
Wait, what day?
What happened?
August 7th.
Oh, that's the day before our birthday.
Wait, what happened?
Because his daughter.
Oh, she's older than us. I'm an expert.
I think that's it.
Okay. Thanks,
Maybe it's
Brooks.
off, but-
That is not correct, but that's okay. You came up and took a risk. Can we see what's the mistake here?
Yeah, just subtract the ones that are overlapping, so it actually adds up to 105.
Okay, so 4 in the middle is good. What goes here?
Eight.
Okay. So. Here. 5. And then what goes there? No. No.
Yes.
Oh, 1, yes.
Oh.
Okay, sorry. Looking at the wrong spot.
Wait, where'd you get the one from?
5 are total in science and English together. So the science and English circle is here. We already placed 4. So 1 more. What goes here? We're big boys and girls. We can do this subtraction in our head.
Where you mind?
And then here. 40. And what about the S, the other part of the S circle?
13.
Yep. Anything else? Hmm? 11 on the outside, that seems unlikely to me. 116, 104, 99, 90, 94, no. So I think 11.
Yeah.
Because how much should it all add up to?
105.
105. So there's part A. What about part B? What's that? 11, right? We just did it. How many students are in nothing? Find n of m prime union, or I'm sorry, m complement intersect e. Okay, I think that seems right. 41. So you want the things in n complement and also e.
Oh.
So we look at the things that are in e but not m.
No.
11.
Okay.
How about P of M union S intersect E complement?
I didn't even miss it.
Well, they're also in the OneNote if you can't read it right now, right? You look in the OneNote too.
The one that is not working.
It's not working?
No, it's not sync. It wasn't working last time either, I just forgot to tell you.
So you want the things in not E that are also in M or S.
40. I added.
Oops.
Yeah.
Over 105.
Is everybody okay? You like what I'm doing with the colors?
Yeah.
Wait,
It's easier to see it, right?
so it's over 105, or is it going to go?
Yeah, why over 105? Why though?
Or you go this now?
Right, because it's an N, not a P.
Okay, so it's.
N is number of.
Okay.
How much is in the set? Good. Now, remember this is the same thing as that, right? Everything that's not in S or U. So that would be these parts in there. So that's 52. Or is in E. So you also have those 9. 52 plus 9 is 60. This is what the homework from 8-1 would look like, right? You did it rather than just copying out of the back of the book. Not that any of you guys do that. Or do the homework, if you didn't do it yet, Anthony.
I turned it on.
Well, you didn't email me that you did it.
Are you serious?
You gotta email us back then too? He gives him the yellow thumbs up. Wow.
This is
Forgot.
what the
Love the yellow
OneNote
thumbs up.
says.
I'll
Content
email you
not
right now.
available. Sorry, looks like this page is added from another computer and has to sync.
Interesting.
You can just watch the video.
I'll take a look and see if I can sort it out. All right. 8-2, talking more probabilities. So, basic probability rules. Probability of any event is between 0 and 1. All possible outcomes together, the probabilities have to sum to 1. If all outcomes are equally likely, the probability that A occurs can be found by using the formula number of outcomes corresponding to event A divided by the total number of outcomes in the sample space. Just like we've done already, right? These are basic ideas that we've already been using to do probabilities in the previous section. The probability that an event does not occur is 1 minus the probability that it does occur. That was the complement rule. We mentioned that last time also. Here are the same rules written symbolically. Right? For the first one, probability is between 0 and 1. The probability of the entire sample space needs to equal 1. Equally likely outcomes, and then the complement rule. Everybody's okay? It's the same thing as the previous slide, just symbolic. So you can classify probabilities, or one way to classify probabilities is into 2 cups, either theoretical or experimental. So theoretical is the number of possible successful results divided by the total number of outcomes in the sample space. So for example, if we're flipping a coin, the theoretical probability of heads is 1/2 or 50%, right? Or if rolling a Monopoly dice, 1 in 6, right? Now, what assumption did you make in both those instances?
It's fair.
That the dice is fair and the coin is fair, that the outcomes are equally likely, right? What if they're not?
Probability is zero.
What could we do?
Roll it 100 times.
You do a bunch of trials and track what's happening experimentally. So we could take that same coin that we don't know if it's fair or not and flip that coin like 10,000 times and record how many heads we get. And maybe we find that, heads on that coin comes out like 53% of the time rather than 50% of the time. And it's like, ooh, cheater, pumpkin eater. Everybody's okay with that idea? Or if it's a dice, you do the same thing. Like you just do a bunch of trials, record what happens, and you build your probability model that way based on an experiment. Everybody's okay with this? A real world example is in baseball. The player's batting average is essentially experimental probability, right? Or if you're talking about like playing darts, like if you're trying to calculate like what's the probability of landing in, this ring or that ring, right on the bullseye. You could do that theoretically, but that assumes that you have equally likely the dart to land anywhere on the dartboard. Usually in games of skill, that's not the case, right? Or you could be good at it or bad at it. Some people can't even hit the dartboard. Henry. All right, so let's take a look at an example to help you understand which one you're talking about. A baseball player has a batting average of 250, meaning he has safely hit a ball and reached base 1 out of every 4 times he steps to the plate. In a particular game, he's gone to the plate 3 times and not reached base. Your friend argues that the baseball player will absolutely safely hit the ball and reach base at his next at-bat. Give 2 reasons why your friend is wrong. Yeah, Henry.
Because you could go like 2 for 3 one day and over the next.
Right. So, like, the idea here is that you're conflating, like long-term probability with short-term result, right?
Yeah.
Does
Sure.
it have to do with the fact that like long-term probabilities? I don't know how you
Basically, a long-term probability is going to collapse to the actual probability. You can have short-term variation, right? You can get hot and go like, have like a 15-game hitting streak where you're batting 350, and at the end of the season, you still end up as 250, right? It's like, still the same lousy hitter I was at the start. I mean, 250 is not that lousy. I mean, it's just lousy for a professional baseball player. If you're not hitting like 50 home runs. Right? If you hit 50 home runs, we can excuse you hitting 250. Okay, what's another reason?
the gamblers.
Yeah, I mean, kind of. Sure. What team they're playing? I would say the other good reason would be you're conflating like experimental probability with theoretical probability, right? Like it's here, if their current batting average is 250, does that necessarily mean that's going to be their batting average for the season? Maybe they're way worse, real badder than 250. You just caught them early on in the season before it's caught up to them. You know what I mean? Maybe they're like 1 for 4, and that's the only hit they're going to have in their career. Like, oops. All right. Mutually exclusive events. We talked about mutually exclusive last time. Who remembers what that means? The name kind of says it.
That's right.
Yeah, they have no overlap. The intersection is empty. They are disjoint. all of those mean the same thing. So if I have the union of two mutually exclusive events, I can find, or I can count the number of things in that union just by counting the number of things in A and then counting the number of things in B. Everybody's okay with that? Similarly, if I want to calculate the probability of a union of mutually exclusive events, I can just add the probability of A to the probability of B. Everybody's okay with that? Examples of events that are mutually exclusive. Give me an example.
Relationship.
No, that's actually
Grande was dating,
DeGrande can date whoever he wants, let's be honest.
Yeah. No, that was the example that Miss Garcia did last year. I was trying to tell her that I forgot which one it was, or like how she said it, but Miss Garcia used that example last year in stats.
Oh.
About dating
yeah,
or
like
something.
DeGrande's dating.
Okay, we don't need
Emerson, but then Emerson's dating.
We don't need to do all this, bro.
Hey.
Okay, just let him do examples, all right?
How about just flipping a coin?
Yeah,
Yes.
Right? Can you get both heads and tails at the same time?
Okay, bro, like
No.
relax.
How about rolling a dice?
Yeah.
Can you roll a 2 and a 3 at the same time?
No.
No.
No, not on one dice.
Not on a flat surface.
Right? No. Okay. Everybody's okay? So let's look at an example here. So this says when people create codes for their cell phones, the first digits follow the probability model shown in the table below. So this is the probability of choosing the first digit of your cell phone passcode. What's the most common number chosen?
4. What? Why would you say that?
1. Why do you think it's 1?
Because it's a first 1, 5, 6, 7.
Okay, 1, 2, 3, 4. But what else?
1, 6, 7, 6, 7. It's the first one.
No, man.
Because it's an in response rate.
It's the closest 1 to 1.
Dude, birth years. Most cell phone users' birth year starts with 19, right?
Boomers.
If you're using a cell phone, what's the most common passcodes to pick?
Your birthday.
Birthdays, birth years, stuff like that. Dates, right? That would be my
The
assumption.
same number over and over.
You just do the same number over and over again?
And then when someone finds it out, I just change the number.
You're a sucker. My passcode is a random series of letters and numbers.
That's smart.
I would never remember.
I would not forget it.
All right. Find the probability that the first digit is 1. 0.3. Not 3. 3 is an insane person's answer, right? No. Well, you don't have to write it as over 1. You can just write it as 0.3. That's fine. How else could you write it?
3%.
Not 3%.
0.003%.
Not 0.33%.
1%.
How about 30%?
Oh, yeah.
Wait.
30%, guys.
Oh.
Going back to middle school, where we're writing percentages out of decimals, right? Everybody remember how to do this? You multiply by 100.
Yeah.
You move decimal point 2 places to the right, not the left. We're okay?
Yeah.
Or 3 out of 10 would be fine also. Okay. Find the probability the first digit is more than 5. What are the outcomes in that event?
Does that include that?
It says is more than 5. What are the outcomes in that event?
Just adding 6, 7, 8, 9.
So 6, 7, 8, and 9 are the outcomes in that event. Are those mutually exclusive events? Can your first digit be both 6 and 7? No. So how do we find the probability then of mutually exclusive events? You just add the probabilities of the individual events.
Yes.
So it would just be P of 6 plus P of 7 plus P of 8 plus P of 9. Into your calculator it goes and you're done, right?
You're gonna have to know how to write it different ways. Like that score could also be like everything that's not 0, 1, 2, 3, 4, 5. You have to write it like just something like that.
It's mostly just knowledge.
Okay.
Is everybody okay with what we did there? Again, what was the key to knowing that I could just add up the probabilities? Mutually exclusive. Is that going to be told to you expressly in the problem?
Probably not.
No. Do you have to be able to read the problem and decide for yourself if it's mutually exclusive or not?
Yeah.
Yes. Is this the part that students stink at?
Well, we'll figure out on the test.
Yes. You know why? You guys don't read. You're just like, oh, let me look at the numbers and get to the math. It's like, no, man, you got to read. Read the problem. All right. Find the probability of the first digit is odd. Okay, which ones?
1, 3, 5, 7, 9.
Every
Yes, just add them up. Just the odds, though, right? Won't be 1 because evens aren't included, right, Emerson? Yeah, you knew that, right? You're just being distracted by the prospect of dating Lucas, so.
Yeah.
Well, more so my sister.
Oh boy!
And Emerson's sister's in 6th grade.
Relax.
Relax.
Relax, bro.
Well,
Okay. So find the probability the first digit is greater than 5. The first digit is 1 or greater than 5.
1 plus 7 plus 6 plus 8.
Great. So the outcomes in that event are the numbers 1, 6, 7, 8, and 9. And again, we calculated some of those things already, so we can rely on previous work. But there's the dealio. Everybody's good?
Absolutely.
How about the first digit is not a 1?
1 minus.
Just add up all
What do you
the
call
numbers.
stats?
I like what Emerson was heading better. She said 1 minus the probability of 1. Why do I like that better than adding up all of them? It's way quicker.
It's easier.
Right? What if there was like 100 digits? It was everything except 1.
You'd have to.
Yeah, it stinks, right?
You're one of
You can be there for a long time adding stuff up, right?
Yeah.
Yeah. That complement rule is really handy. Now in this case, sure, you could add them all up. It's not that big of a deal. There's only 10 things. You know, adding up 9 of them, no big deal. But like, we're gonna look at situations where there's maybe infinitely many things. Shh. And adding them up becomes like impractical. I know, that sounds exciting, doesn't it? Find the probability that the first digit is odd or a number greater than 5.
1, 3, 5, 6, 7, 8, 9.
No, because that's to be larger than 1. Oh, wait, never mind. Wait, what is OR? Is that the union or the?
Well, yeah, what is OR? Is it union or intersection? It is union.
It's union.
That is correct.
So it means it can be either one, right?
Correct.
So I think Brooks is right.
Yeah, what do you have to be careful about here?
Because If it was just and, then it would be the 7 and 9.
But what do you have to be careful about?
Union or not? Or like, I don't know what we're doing.
Are the events odd number or larger than 5 mutually exclusive?
No,
No. Why not?
because there's numbers that are larger than 5.
Correct. What are those two numbers? 7 and 9. So when you're doing this, you must do it the way that Brooks described, by just adding the probabilities of 1, 3, 5, 6, 7, 8, and 9 together. You cannot take your answer for odd plus your answer for larger than 5, because you've counted 7 and 9 twice in doing so. Does everybody see that? What's up? Okay. I wrote it down, right? So notice that if you didn't account for the mutually exclusive, you get a different answer, right? We would have gotten 0.824 doing it the wrong way, but 0.721 doing it the correct way. And the reason you get the wrong answer doing it the wrong way is you're counting the number 7 and 9 twice in doing that. Oh no! It would, wouldn't it? So my last point here is that you can do this by looking at the probability of first digit is 5 plus the probability that the first digit is odd if you then subtract the intersection of those two, i.e. if you do this. And then you'll get the same result. And in fact, that becomes the formula for the probability of overlapping events. Okay, so the probability of event A plus the probability of event B, event B minus the probability of the intersection of events A and B. Okay. Everybody cool?
Yeah.
Let's do some examples.
Yeah.
I know, I'm excited too. Below is a probability model for students who took the 2013 AP Statistics exam. Prove that what we're looking at is a legitimate probability model. Good, that they need to add to 1, right? They will. What else do we need? Do we need to do anything else? I can't remember. I don't think so. Yeah, that's it. All right. Part B says find the probability that the chosen student score is at most 5, or I'm sorry, at most 2. What does at most mean?
Less than.
Good. So how do I do the probability that x is less than or equal to 2? P of 1 plus P of 2. Do I need to subtract the intersection of 1 and 2? Why not? Yeah, what is it called? Yes. Woo! Or, what else could you call it? Start with a D. Disjoint. All right, find the probability that a chosen student's score is at least a 3. How do I write that? At least a 3. I want the inequality first, though.
Oh.
What does at least mean?
Greater than or equal to 3.
Good. And you don't need me to like write the numbers down and add them together. Right? Nobody needs that. I hope. Oh, thank goodness. There are 30 students in a stats class. After taking a poll, the teacher discovers that 20 students play an instrument. 18 take art. 12 do both. Construct a Venn diagram of the situation above. How many circles am I going to get? 2. Okay. Everybody okay with how we started drawing this? Okay. Where do I start labeling?
In the middle.
Middle. What do I put in there? Okay. What do I put in the rest of I?
30 minus
8. How'd you get 8? Subtracted what? 20 minus 1. Okay, what goes in the rest of A? 6. Is that it?
No.
Why not?
There's 30 left over, so 30 in the outside.
There's 4 left over because 8 plus 12 plus 6 is 26, and there should be 30. So it's 4 unaccounted for. How many students take art but do not play an instrument?
6.
Okay. So we're okay how I translated that symbolically. Take art and do not play an instrument. We're okay with the implied and in that statement. What is the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample is identified as a high school graduate or not, and a homeowner or not. The two-way table displays the data. Use symbols to define all the possible events for the data above using high school graduates and homeowners. What is this one? H and G, correct? That 221s are people that are homeowners and high school graduates, correct?
Yes.
H and G, or H intersect G. Agreed? Okay. What is the 119? H and not G. How about the 89? Okay, and then the ones or the 71?
Not H.
Does it matter the order that you write? Because you've written G and H. Yes, that's fine, right? Intersection, union, both commutative. Means you reads the same way forward and backwards. Yep. Suppose you choose a member of this sample at random. Find the probability the member you chose is a high school graduate. So this is just P of H, right? Well, that's actually right, but P of X equals H. So 310 out of 500 or 31 out of 50, either is fine. Or you could convert it to a decimal, 0.62, or as a percentage, 62%. Any above of those are fine, right? High school graduate and owns a home. Is a high school graduate or owns a home. What did I just do? I did P of H. No, I did the wrong thing. I meant this to be, that's not right. That's supposed to be 340. I did P of H plus P of G minus P of H and G. Why did I have to be careful here? Yeah. Now, could you've done this another way? Yeah. This is the systematic way of doing it, where it's like the same way every time. How else could you have you done this? 89 plus 71 plus 119. Oh no, 89 plus 119. Excuse me. Oh my gosh, don't come in and interrupt.
Sorry. They can't fix it. Well, actually, it's complicated. High school
Sure, yeah, okay, sorry. Yes. This is why I don't like doing it. Yes, 89 plus 221 plus 119. Yes. You can do it that way as well. All right, construct the Venn diagram. Okay. Where do I start filling? Middle, what goes in the middle? 221, right? What goes in the rest of H? 119. What goes in the rest of G? What goes on the outside? Everybody okay? What do you guys think?
For that, would you recommend that we just look at the table?
Yeah.
Instead of like a large.
Yeah, I don't think the probability help as much help there. I think the tables, that's all I would be looking at. All right. Everybody okay? Just a little due date rundown. By Friday, introductions. Right? Where do you get the details for writing your introduction? On the OneNote, which apparently I need to make sure I fix to get you guys access back.
No, the
Uh,
other ones work.
Oh, the other ones.
It was just
Yeah,
that
just
one.
the 8.1.
That's insane. Why that's the only one? Maybe. Okay. What's due after you get back from break? No, before the IA is due.
She's got jokes.
Before the well, yeah, homework, but like the Excel sheet of your calculations, that's due Monday when you get back from break. Okay. What's due on the following Monday? The IA, the full dog, whole hog. Okay. What?
I'm doing all my eyes.
Wait, would it be the Tuesday? Like